Black holes have long been the mysterious, menacing monsters of the cosmos, devouring anything that ventures too close and warping the very fabric of space and time. For most of human history, they were theoretical constructs, ideas born in the minds of physicists trying to understand the extremes of gravity. But as our tools for exploring the universe have improved, we've discovered that these enigmatic objects are not just out there. Some are surprisingly close. Among these are three recently identified black holes, the so-called Gaia black holes, residing in our cosmic backyard and named after the observatory spacecraft that discovered them. Gaia BH1 is located in the constellation Ophiuchus, about 1,560 light-years away. Gaia BH2 is in the constellation Centaurus, about 3,800 light-years from Earth, and Gaia BH3 is 2,000 light-years away, in the constellation Aquila, making it the second closest black hole to Earth. Using data from the European Space Agency's Gaia Observatory, astronomers have pinpointed these black holes based on their gravitational effects on nearby stars. Gaia is a spacecraft designed to create the most precise 3D map of our galaxy, and in doing so, it has revealed the subtle wobbles in star movements caused by the invisible pull of black holes. These Gaia black holes are located only 1,000 or 2,000 light-years from Earth, practically next door in astronomical terms. While they may seem far away to our everyday understanding, in the grand scale of the Milky Way, they're uncomfortably close. The risks posed by these black holes depend on their distance and trajectory. Currently, none of the Gaia black holes are on a collision course with our solar system, which is reassuring. However, their gravitational influence could become a significant concern if one were to drift closer to us. For a black hole to pose a direct threat, it would need to come within a few light-years of our solar system. But if such an event were to occur, the consequences could be catastrophic. One of the first and most dramatic effects of a black hole approaching our solar system would be its impact on the Oort cloud, a vast shell of icy bodies surrounding the Sun at the edge of the solar system. The immense gravitational pull of the black hole could dislodge comets from their stable orbits, sending them hurtling toward the inner solar system. This would dramatically increase the frequency of cometary impacts on planets, including Earth. Some of these impacts could be catastrophic, releasing enough energy to rival the asteroid that wiped out the dinosaurs. Closer still, the black hole's gravity would begin to disrupt the orbits of the planets themselves. At first, the effects would be subtle, with slight changes in the length of years or shifts in orbital eccentricities. Over time, however, these changes could escalate. Planets might be ejected from the solar system entirely, or drawn into erratic, unstable orbits. Such chaos could strip the Earth of its habitability, either by plunging it into extreme cold as it drifts farther from the Sun, or scorching it as it spirals closer. The Gaia black holes are relatively small by black hole standards, with masses of a few times that of the Sun. These stellar mass black holes are formed when massive stars collapse under their own gravity at the end of their lives. Despite their modest size, they are incredibly dense and pack a gravitational punch far beyond their mass. If one were to come within a few light-years of us, the distortion it would cause to space-time could affect not just celestial mechanics, but also the trajectories of interstellar objects. The closer it gets, the more intense its effects would become. The idea of a black hole drifting into our cosmic neighborhood is not purely hypothetical. The Milky Way is a dynamic galaxy with stars and other objects constantly moving through it. Some black holes, particularly those in binary systems, can be ejected from their original locations by gravitational interactions or supernova explosions. A rogue black hole wandering the galaxy could easily cross paths with our solar system, given enough time. In fact, some astronomers believe there could be millions of such black holes roaming the Milky Way, invisible except for the gravitational clues they leave behind. The good news is that detecting these black holes, as Gaia has demonstrated, is becoming increasingly feasible. By observing the wobble of nearby stars, astronomers can map the presence and movement of these invisible giants. This gives us an opportunity to understand their trajectories and predict whether any pose a future risk. One fascinating aspect of black holes is how they interact with their surroundings. Most of their gravitational effects occur outside of their event horizon boundary, the point of no return where not even light can escape. If a Gaia black hole were to pass close enough to our solar system, it could distort space-time itself, bending light from stars and creating spectacular gravitational lensing effects. This phenomenon, where the black hole acts like a cosmic magnifying glass, could provide astronomers with an unprecedented view of distant galaxies and cosmic structures. If the black hole came even closer, it might begin to siphon off material from the outer edges of the Sun. This would form an accretion disk, a swirling ring of superheated gas and plasma spiraling toward the black hole. Such a disk would emit intense radiation, making the black hole temporarily visible as a bright X-ray source. The radiation from this process could pose additional risks to life on Earth, potentially stripping away parts of our atmosphere and exposing the surface to harmful cosmic rays. While these scenarios are unsettling, the likelihood of a Gaia black hole or any black hole disrupting our solar system in the near future remains exceedingly low. Space is vast, and the distances between stars and black holes are enormous. Even at their closest, the Gaia black holes are separated from us by hundreds of trillions of miles. Still, their presence serves as a humbling reminder of the forces that govern the universe and how small and fragile our existence is in the grand cosmic scheme. The discovery of the Gaia black holes is not just a tale of potential doom, it's also a triumph of human ingenuity. The ability to detect these invisible objects through their gravitational effects is a testament to the power of modern astronomy. As we continue to study these black holes, we gain a better understanding of the universe's most extreme phenomena, from the formation of stars and galaxies to the limits of space-time itself. Black holes, particularly those in our cosmic backyard, are a paradox, silent, invisible, and deadly, yet also sources of wonder and discovery. The Gaia black holes remind us of the delicate balance that keeps our solar system stable and the immense forces that could disrupt it so easily. For now, the Gaia black holes are safely distant, but they are a clear example of the potential dangers in the vast expanse of the universe. I'd like to thank you for spending time with us as we look into the Gaia black holes and invite you back for our next episode of A Godless Universe.